Today, as Roz kindly introduced, I'm Sacchi. I'm actually a PhD student in the Museum of Zoology. I'm in the insect ecology group, but my PhD research actually focuses on working on making palm oil a little bit more sustainable. So when you read the title or when Roz introduced me, you might have been a little bit confused because you don't often hear sustainability and palm oil in the same sentence. Despite the fact that it has a horrendous public image, it is the leading source of vegetable oil worldwide, and it is extremely versatile. It's not just used as a cooking product. I bet if you were to go home, you would find it in a lot of your common household items, like your shampoo, your makeup. It's used a lot to make other plastics. And in just 1 year, about 74 million tons was produced. Now, usually, I think it's pretty safe to say it's probably the crop that's the most associated with deforestation and environmental damage. So really the question is, why do we continue to farm it if it is so costly to our environment? Well, I'm going to say something that could potentially be quite problematic, or you might disagree with me here, but I do think it has the potential to be sustainably managed. And the reason why is that it has a couple of key features that make it more eco-friendly than what other eco-friendly options have been put forward to you. For one, it has a much higher yield per hectare. So in comparison to other oil types that you might have been put forward as more eco-friendly, like rapeseed oil or sunflower oil, it's actually got 4 to 8 times higher yield per hectare. What I mean by this is that you'd have to use 4 to 8 times more land to produce the same amount of oil if you were to switch to the other alternatives. Another feature is that it's replanted every 20 to 25 years. In contrast to most agricultural crops, which are replanted every single year, it's a lot less intensive on the environment if you're not having to go in every year and rip it up. And during that time, there are a lot of animals that live in these areas that could actually use these areas within the plantation as habitats. So really, what my lab group is looking at is how to tweak the way that we manage these landscapes to hopefully make it more sustainable and use these features to our advantage. Now, the top 2 producers of palm oil at the moment is Indonesia and Malaysia. So together they produce about 84% of the global production. This is a little bit of a concern because tropical forests are what we know of as like the ecocenter of biodiversity. They hold about 2/3 of the entire world's biodiversity, despite being really small in Earth land surface area. So if there's anything that I want you to take away from this presentation, is that it's not the crop itself that's really the cause behind the mass deforestation, it's the way that we manage agricultural landscapes, because we continuously clear hectares and hectares of area of natural forests and turn them into these monocultures of plantations. So looking at this from a conservation lens, this is rather scary. It's not natural to just see one crop going for thousands of hectares in one area. If you look at it from an agricultural perspective, it's also not good because all the animals that we rely on to provide services like pollination, they're not going to be very happy living in this area. So they're not going to create habitats, pollination goes down, agriculture suffers as well. So really, instead of thinking about it as 2 opposing objectives of conservation and agriculture, what we're really trying to think of is how can we merge these 2 together so that we can actually create a landscape that achieves both of these objectives in one go. So this is what my PhD focuses on, and I work in Indonesia, which is the top producer of palm oil in the world. I work in Riau, which is above Jakarta. We focus on the restoration of riparian margins, which is just really a fancy word for a river margin edge, so just the land that's next to a waterway. And since 2018, we've been restoring these areas in established oil palm plantations in Indonesia to see what is actually effective in restoring these areas that are beneficial for our animals. So there's a lot of fancy words and stuff, but really, we've got a lot of different treatments that we've tried. The first one is what I call active, because there was a lot of human labor put in. We did a whole bunch of series of enrichment plantings with different tree species. The next one I call passive because really we just left the margin to do whatever it wanted on its own. There was no intervention. We just saw how it sort of recovered itself. This one is active again. It's very similar to the first one I described because we did the same series of plantings with trees. But in this case, we removed any old palm oil that was in there because we wanted to see if being unshaded during early development had an impact on restoration. And lastly, because we want to make sure that anything that we're seeing is actually due to what we're doing rather than just by chance, we had to have a control in our experiment. So this is a really long-term, ongoing project. There's so many people involved. But what do I actually do as a conservation ecologist? What am I doing for my PhD? Well, I'm doing a lot of data collection. I'm really fortunate for the fact that I was able to go out to Riau, Indonesia for 2 field seasons so far, and I was able to collect lots of different aspects of the environment to see what we're doing. Is it actually working? Is it not? Hopefully it is working, otherwise some people really won't be happy. And there's all these different aspects that I collected. There's a lot of nets, chasing insects with clipboards, things like that. For today, because it's a little bit more interesting, I thought I would highlight some of the cool tech that I got to use for my PhD. So this is vegetative structure and temperature. So what I did for vegetative structure is I used this really cool piece of equipment called a terrestrial LiDAR scanner. Now this is essentially a very fancy camera, but it uses laser beams to be able to reconstruct a 3D image of all the vegetation that's around it. And essentially the way it works is if you see that spinning bit there, that's a mirror that's continuously spinning whilst a whole bunch of laser beams are being shot out. And as soon as they hit a piece of vegetation around it, it measures that distance. And it's able to recreate a 3D image of all the vegetation that's around it. Another thing that I got to do was I got to use a thermal camera. Now, I've always been wanting to use one, so it was great that I could push this forward and get some funding to buy one. Essentially, there's over 300,000 pixels in the 4 images combined. I took an image of the ground in 4 directions, northeast, southwest. I did it in the morning and I did it in the afternoon. It's a great way of getting a snapshot of what's going on in the environment at that time. And every single one of these pixels has a temperature data point in it. So I was able to extract that out and I was able to identify the hot and cold patches that are within every frame. Now, just because I think this is really cool, I thought you guys might also like to see the amount of detail that you can get from a terrestrial LiDAR scanner, and my scans were only 5 minutes. They can go up to an hour, depending on how detailed you want to be. So we've got the shaded treatment and we've got the control treatment here. I'm hoping you guys can see that the amount of vegetation in this shaded treatment is just so much more complex. And another thing is that up above, there's a lot less open canopy area as what you can see with control. The control is just really open. It got really hot in there. Just from personal anecdotes, I didn't like working in the control treatment because it was a lot hotter during the day, especially in Indonesia in the hot season. Now this is some pictures that the thermal imaging was able to produce. So you've got the average temperature here and you've got the range on the side of basically a summary of all the temperatures that was recorded. In the shaded treatment, you see that it is just overall a lot lower in the temperature, both in the morning and in the afternoon. If you were to compare it to the control, you can see that it's nearly 10 degrees hotter, and also the range of how much it jumps from the morning to the afternoon, because the maximum temperature in the morning was around 30, and that was nearly the minimum temperature in the afternoon. So you can just see that having a little bit of extra shading has a massive impact on what temperature is actually happening in these river margins. So really, with just a little bit of investment, river margins can really accelerate and get back to forest-like features, because this project has only been going on for about 6 years now. So it's amazing to see how much it's able to be restored in a short amount of time. we can see that restored river forests help buffer those hot temperatures, and that is really critical for animals that we rely on for agriculture, such as insects. They're really small, they're not good at maintaining their own body temperature, so by creating these areas that they can sort of seek refuge, especially because we know that climate change is going to be quite a big, hard-hitting impact, these margins could provide a really good refuge for them. And lastly, we see that investing in just a few plantings seems to be way more effective of restoring or accelerating the recovery process. So lastly, I should say that this is a huge collaboration. All the hard work essentially happened before I got involved, and now I'm just sort of coming along at the end with really cool equipment. But thank you so much for listening, and does anyone have any questions?